Welcome to our exploration of information science. Dr. Patel, to kick things off, how would you define information science and what distinguishes it from fields like computer science or library science?
Great question. Information science focuses on the collection, organization, storage, retrieval, and use of information. Unlike computer science, which emphasizes algorithms and computation, or library science, which centers on managing physical collections, information science bridges technology and human behavior to optimize information flow.
That boundary-crossing nature is fascinating. Can you provide examples of how information science impacts our daily lives, perhaps in ways we don't immediately recognize?
Absolutely. Every time you search for a restaurant online or a book in a digital library, you're benefiting from information retrieval systems designed by information scientists. Even recommender systems on streaming platforms rely on principles from this field to filter and present content relevant to you.
So it's embedded in both our digital and physical environments. To lay the groundwork for our deeper discussion, what are the main pillars or domains within information science as an academic discipline?
The core domains include information organization, information retrieval, information behavior, and information policy. Each domain tackles unique challenges, for instance, how to efficiently categorize massive data or how privacy laws affect data sharing across borders.
Building on those pillars, let's transition to how information science has evolved. Historically, much of the field revolved around archiving paper documents. What sparked the shift toward today's focus on digital and big data?
The digital revolution was transformative. As information volumes exploded, traditional filing systems became inadequate. By the 1980s, the emergence of electronic databases and the Internet pushed the field to develop new frameworks for managing unstructured, vast datasets. Think of transitioning from card catalogs to Google search algorithms.
That's a dramatic shift. How did information scientists adapt to the challenges of digital information overload? And what new techniques emerged as a result?
Two major responses were metadata systems and sophisticated search algorithms. Metadata acts like a digital librarian, describing content so it's easily findable. Simultaneously, advances in machine learning allowed systems to sift through billions of documents and present the most relevant ones in milliseconds.
Could you compare this progression to another field for context?
Certainly. It's akin to transportation, moving from horse-drawn carriages to high-speed trains. The core need, getting from point A to B, remains, but the scale and speed necessitate new tools and thinking.
Now that we've covered technological advances, let's focus on how humans interact with information. What does information science reveal about human information behavior? And why is this crucial in our data-saturated world?
Information behavior explores how people seek, use, and avoid information. Studies show individuals often rely on satisficing, choosing the first solution that meets their needs rather than the optimal one. This is partially due to cognitive overload. Our brains can't process endless options efficiently.
That's a relatable challenge. Are there strategies or systems designed to help users navigate overwhelming amounts of information more effectively?
Yes, personalization and visualization tools are key. For example, news aggregators use algorithms to tailor content to your interests, and data dashboards convert complex datasets into charts, making patterns easier to grasp. Both aim to reduce friction and support better decision-making.
Given the risk of filter bubbles with these personalized tools, how do information scientists address concerns about bias and access to diverse perspectives?
It's a critical issue. Some platforms now incorporate serendipity algorithms that occasionally introduce outlier content, counteracting echo chambers. Additionally, ongoing research focuses on transparent algorithm design to ensure fair and equitable information access.
As we look forward, the ethical dimensions of information science are increasingly prominent. What are some pressing ethical and privacy concerns shaping the field today?
One major concern is data privacy, how personal information is collected, stored, and shared. For instance, A 2022 Pew Research study found that 81% of Americans feel they have little control over their online data. This drives debates around consent, surveillance, and digital rights.
With regulations like the GDPR in Europe, how are organizations adapting their information management practices?
Organizations now prioritize privacy by design, embedding safeguards into systems from the outset. They must also provide greater transparency, allowing users to see and manage their data footprints. Compliance has become both a legal requirement and a competitive differentiator.
Looking ahead, what emerging trends should we watch in information science, especially as AI and quantum computing advance?
We're entering an era of intelligent information ecosystems. AI will automate more complex information tasks, while quantum computing could revolutionize encryption and retrieval speeds. However, alongside these innovations, the need for ethical frameworks will only intensify to balance progress with public trust.